Okay, here we solve the numerical that is related to the AC circuit chapter. That is numerical. Here is the given data, that is the resistor of resistance is 30 ohm is connected in series with a capacitor of capacitance is 79.5 microfarad across a power supply of 50 hertz and 100 volt. In the A part, find the impedance, B part, find the current, C part, find the phase angle, and D part, find the equation for the instantaneous value of the current. So here we write that resistor value that is equal to 30 ohm is connected in series with a capacitor, that is value is given 79.5 microfarad. Micro, we know that it is equal to 10 into minus 6. So it is can be write as 29.5 into 10 to the power minus 6 farad across a power supply, that is the frequency is given 50 hertz and voltage that is the 100 volt. In the A part, find the impedance. B part, find the current. C part, find the phase angle. And D part, find the equation of current. So here we first find the A part. A part, we find the impedance. We know that the impedance formula that is equal to, here we use the circuit that is constant of resistor and the capacitor. So impedance in the case of resistor or capacitor is become R square plus X C square. That is the resistance of the resistor that is denoted by R and the resistance of the capacitor that is denoted by X C. So we combine them, S square and S square root, we find the impedance of this circuit. So here we know that the formula of the resistor is given, but the formula of the XC is not given. By finding XC using this formula, here we know that the XC that is equal to 1 over omega C. We know that the omega that is equal to 2 pi f. Put it here. So it is equal to 2 pi f c. So here we find that pi that is equal to 3.1416, frequency that is equal to 50 hertz, and capacitor value that is given the 79.5 into 10 to the power minus 6 farad. So here we find the value of the capacitive reactance that is equal to 40.04 ohm. Okay, okay. Okay, now move to the our main formula of the impedance, that is the Z. Put this XC into this formula. So here we find the value of the resistor that is the 30. Put it here, 30 square, and the XC that is equal to 40.04 ohm square. We square and plus and taking the under root, we find that the impedance that is equal to 50.03 ohm. That is, we find the impedance of the circuit that is constant of the resistor and the capacitor. Here we find the A part, now we find the B part, that is the current. Okay, here we find the current, that is the root mean square current. So here is the find the current value of the voltage that is given the 100 volt. We can use the formula of the Ohm law, that is equal to V is equal to IR. R is equal to V over I. V that is given that 100. We find the I. So here we rearrange the formula, that is equal to V over R. V that is equal to 100. R that is given the 30. So here we find the value of the current that is equal to कुछ गड़बड़ हो गया. Here we use the, in the case of resistor, we use the combined resistance that is denoted by Z. So here we use the value of the impedance. So here is V is equal to Z and I is equal to V over Z. Value of Z, we find that the, so here we find that I is equal to V over Z. V that is given the 100 and Z that is given the 50.03. So value of the current become 2 ampere. So that is, we use the formula of the impedance, because here is the both the element capacitor and resistor. So we use the impedance instead of the resistor R. Okay हो गया. Here we use the whitener. Now you easily understand how we find the current by using the formula of the Ohm law. In the case of the resistors, we use the combined resistance that is noted by Z. We find the current. That is the I and that is the Z. We use this formula. V is equal to IZ. Okay, now we find the third part. In the third part, that is the C, we find the phase angle. We use the formula of the phase angle, that is the phi is equal to tan inverse x c over r. Tan inverse x c, that is, we find that is equal to 40.04 ohm and the resistor that is equal to 30. So put it here. So phi angle that is equal to 53.16 degree. That is the phase angle. Now we find the part, that is the equation. So for the equation, we know that is equal to I is equal to I naught sine of omega t plus phi. Here we know that omega that is equal to 2 pi f. Here we find the omega that is equal to 2 pi f. 2 pi f, that is the frequency f that is given 50 hertz. So omega, it is equal to 314.6 hertz. That is the omega value. Okay, how we find the I naught? For I naught, we use the value of the root mean square current, that is equal to I naught over under root 2. We find the I naught by rearranging the formula. Under root mean square current, value, that is we find the here is, that is the 2. So 2 under root 2, that is equal to 2.82. So here is the equation, that is become I is equal to I naught sine of omega t plus phi. Here we find the I naught, that is equal to 2.828 sine omega, that we find 314.16 t plus phi, that we find at 53.16 degree. That is we find the part.